20 days ago, I published a short video explaining my logic of my constant time and space solution of the problem number square from CSES online judge. I want to thank Mega Plusful who motivated me to make another video in order to explain in deep the solution. Promises made, promises kept. I'm going to make some observations to generate the general formula. I admit it is not easy to see this logic or the way to solve this problem. Frankly, I spent a lot of time to find it. Stay tuned, guys. You will never regret watching. Let's see first the problem statement. A number spiral is an infinite grid whose upper left square has number 1. Here are the first 5 layers of the spiral that you see here in the image. Your task is to find out the number in row Y and column X. The first input line contains an integer t, which is the number of tests. After this, there are t lines, each line containing integers y and x. For each test, print the number in row y and column x. For example, here we have 3 tests. The number in row 2 and column 3, it's 8. Row 2, column 3, 8, as you see here. The number in row 4, column 2, row 4, column 2 is 15, as you see here. Okay. Of course, there is a naive approach. If you figure out or you find a way how to build this matrix, personally, I didn't figure out how to build it. If you figure out or find a way how to build this matrix, you can then easily find the number in row Y and column X. But the time complexity of this solution is quadratic, same for the space complexity, because first you have to pre-process or to build the matrix. Okay. The size of this matrix, you have first to compute the maximum value between all the y's and x's. For example, if I come back to this example here, we have y's 2, 1, 4, so we have 4 here, and the x's 3, 1, 2. You can build so a matrix of size 4, 3 or 4, 4. But as I said, you have first to figure out how to build this matrix, because it's not easy. I don't know how to build this one. Can we do better? Of course, we can do it in constant time and space. There's no need to build this matrix if we think how to use our math or logic this problem. Let's see the first observation. As you see here, here is the spiral. This is the spiral, and as we observe here, we can build a square of size 2 that contain all the consecutive integers from 1 to 4. Same for the square of size 3, or the consecutive numbers from 1 to 9. Same here. Square of size 4, contain the consecutive integers from 1 to 16. Here, square of size 5 from 1 to 25, etc. Until the end of the matrix. This is the first observation. So we have squares here, as you see. The second observation, if y is even, we can see that the element or the number at the row y, column 1, is y squared. As you see, for example, for 2, at row 2, we have the element 4. At row 2, column 1. Same for at row 4, we have 16 here. Same for row 6, we have 36. Same for row 8, we have 64. And same for the x, well, the x's, but if the x is odd, not even, if x is odd, so the element or the number at the row 1, column x, is x squared. As you see, for 1 here, for 3, we have 9, for 5, we have 25, we have for 7, we have 49, and for 9, we have 80, 81, etc. So, okay. The third observation, let's take this example. We have, for example, we want to compute or to know, to figure out the number at row 4, column 3. We can use this line, as you see, to find this answer, which is 14. So we can use this line. Why this line? Because we can use the square where y is even, so we have 16, y squared. 4 squared is 16, so we can compute from 16. So as you see here we have 16 minus 0, we can say. For 15, we have 16 minus 1. For 14, we have 16 minus 2, which is here 16 minus 0, which is 1 minus 1, 2, 16 minus 1, which is 16 minus 2 minus 1, for 14, which is 16 minus 3 minus 1, etc. But as you see here, we can stop here. We cannot use this formula for this element, for 22, for example. So the relationship is broken. So for now, we can say that to find this element, 14, we can compute y squared minus x plus 1, which is 16 minus 3 plus 1. Because I said for this formula here, let's compute it. We have minus x minus 1. It's minus here, which is equal y squared minus x plus 1. It's the same formula here. Let's see the example on the right. We have y is equal to 5, so we have to find out the element at row 5 and column 5. We can use this line. Okay, because we have the square here, and this element 17 is equal to 16 plus 1, 18 is equal to 16 plus 2, 19 is equal to 16 plus 3, and 20 is equal to 16 plus 4, and 21 is equal to 16 plus 5, which is x. We can use this element to compute. So this element. So the formula is y minus 1 square, because y is even, y is odd here in this example on the right, y minus 1 square plus x. So in this case, as you see, we have y's must be greater or equal to x, because if y is less than x, for example, let's take y is equal to 3 here, for example, so we can use this square, and to compute 23, we have to use this element. 4 plus 1, 4 plus 2, 4 plus 3, 4 plus 4 is, so as you see here, the relationship is broken. So for x, for y is less than x, it doesn't work, this formula. So the formula, when y is greater or equal to x and y is even, we can use the square where from y square here, this one, and to compute the element at row y column x, we can use this formula, which is here in the first, in the next element on the right from y square is y square minus 1, here y square minus 2. So we have here y square minus x minus 1, which is y square minus x plus 1. For here, if y is odd, so we will use the square for y minus 1, the square. Because y is odd, y minus 1 is even. This is I have this from the first observation. Don't forget, guys, that I have this observation here. I observed that if y is even, we can compute the element at the row y, column 1. Same for if x is odd, we can compute the element at the row 1, column x. Okay. So we can use the square here because y is odd, so my y minus 1 is even. So here we have y minus 1 square, and this row y minus 1 column 1. And to compute the element at the row y, here we have the row y. We can use this formula, y minus 1 square plus 1, we have there. And here y minus 1 square plus 2 plus 3, etc. until y minus 1 square plus x. X. You see. Okay. Observation 4. So if we take now y is less than x, we have x is equal to 7 here, not 6, to correct this. Okay, y is equal to 5 and x is equal to 7. So we will use the square where we can compute the element at the column 1, row x, which is 49. So we can use that line. Okay, we can use that line to compute the to figure out the element at row 5, column 7. So this square we have we can use this square. Using that element, we can compute that one. Using this formula, same here, same logic, which is y square minus x plus 1 is equal to 45. Same case where x is greater than y, but now x is even, is not odd. So we can use that line where we can compute 30 because the element at row 5 column 6 is 30. How to compute that line? We're going to use the square because we can use this element 25 because x is even, so x minus 1 is odd, so we can find out that the element at the column, the row 1 column 5 is 25 because x minus 1 is odd, which is equal to 5. So we can compute 30 here. Same logic here. We can use this formula, which is x minus 1 square plus y. So in general case where x is greater than y, and if x is odd, we can use this square and we can compute the elements here. That row 2, for example, row 2 column x is x square minus 1. Here at row 3, x square minus 2. So at row y, which is x square minus y plus 1. Same logic of the previous case. Same here. If x is even, so x minus 1 is odd, so we can compute its square. We can use that square to compute the element in the next column, which is the first element is x minus 1 square plus 1, here plus 2, plus 3, etc., and plus y. So, general formula, if x is greater or equal than, if y is greater or equal than x and y is even, so the answer will be y squared minus x plus 1. If y is greater or equal than x and y is odd, so the answer will be y minus 1 squared plus x. And if x is greater than y and x is odd, so the answer will be x squared minus y plus 1. And if x is greater than y and x is even, the answer will be x minus 1 squared plus 1. This is the C++ code. You will find it in the description. As you see, it's accepted and like judge. Guys, don't forget to subscribe if you like this video, and comment and notify the channel to have any incoming video. Thank you for watching, guys. See you soon.